Hello students, welcome to our YouTube channel Experience Tutor. Today we'll discuss class 12th mathematics continuity and differentiability part 5. Before we start, we request you to subscribe, like and share our channel among your friends and relatives. Please click on the subscribe button to support us and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Let us begin today's lesson. In the last session, we have discussed about all the formula used for derivatives. In today's session, we'll see few of the examples of derivatives. First example, find the derivatives of the following function with respect to x. Under root 3x minus 2 for x is greater than 2 by 3. So let fx is equal to under root 3x minus 2 is equal to, we can write 3x minus 2 to the power half. Now f dash x is equal to, we'll use the formula dx to the power n upon dx is equal to n x to the power n minus 1. So using this formula, half is in the place of n and 2x minus 2 is in the place of x. So using the same formula, we have half 3x minus 2 to the power minus half. D upon dx 3x minus 2. Upon solving, we get half 3x minus 2 to the power minus half, and upon solving d 3x minus 2 upon dx, we get 3. So which is equal to 3 upon 2 under root 3x minus 2. This is the answer. Let us see the next example. So next example is, we have to find the derivatives for 2x plus 3 to the power 3 by 5 by 3 x plus 5 to the power minus 1 by 3. So let y is equal to 2x square plus 3 5 by 3 and x plus 5 to the power minus 1 by 3. Differentiating with respect to x, so dy by dx is equal to 2x plus 3 5 by 3 d upon dx x plus 5 to the power minus 1 by 3 plus d, so x plus 5 to the power 1 by 3 minus 1 by 3 d 2x plus 3 to the power 5 by 3. So which formula we are using here? We are using here d u v upon dx, which is equal to u dv upon dx plus v du upon dx. Simple thing. So now we'll solve to its simplest form. So upon solving, we get, upon implementing the formula, we get the step, and upon solving, we get the next step, which is this one, just simplification, nothing else. So again, we take common as 1 by 3 2x square plus 3 to the power 2 by 3. So this expression came out of this. We take common, and upon solving, again we get the step. Next step, upon solving, we get this step, and lastly upon solving we get this one. Upon solving, we get the last step. Let us see the next question. So the next question is find dy by dx if y is equal to sine qx cos to the power 5x. So dy by dx is equal to sine qx d cos to the power 5 cos to the power 5 x plus cos to the power 5 x and dx. Cos to the power 5x d sine qx upon dx. Upon solving, we get sine qx multiply by 5 cos 4x multiply by cos x, the differentiation is sin x, plus cos to the power 5x d sin qx we can write as 3 sin square x, sin x differentiation is cos x. Upon solving, so what we have done here, it is simple. D, the formula which we have used is differentiation of, let us, so the formula which we have used is differentiation of ub upon dx is equal to u dv by dx plus v du by dx. That's it. So in the next step, upon solving this, we can write minus 5 sine 4 minus 5 sine to the power 4 x cos to the power 4 x plus 3 sine square x multiply by cos to the power 6x. Here one more thing you have to remember, that is in this case, so anything in this term, for example cos to the power nx can be written as cos x to the power n. Similarly, same we can write for the sine. So this is the answer. Let us move to the next question. So the next sum is find dy and d under root sine qx upon dx. So we can write d, so we can write d under root sine xq upon dx, which is equal to d by dx sine xq to the power half is equal to half sine xq. Half minus 1 dot cos q multiply by 3x square. Here we have to understand what we have done. Here in this step, we have used dx to the power n dx is equal to n x n minus 1. So half is in place of n, and this x sine q is in place of x. So if you just directly put the formula, this will come. Now what we have done here, this is very simple, just differentiation of cos xq dx. If you this is sine x, so this came by differentiation of sine xq upon by dx. Again, from where this came, this is also very simple. We have differentiated xq, then we'll get, and we have used the formula dx to the power n dx, which is n x n minus 1. If we put this formula here, you will get the value 3x square. Now let us see what is the next part. So next part is easy, just you simplify the index, that is minus half and multiply by cos xq 3x square. So upon simplifying, we get 3 by 2 x square, rearranging, just simplifying and rearranging, cos xq upon sine xq to the power minus half, then upon root. That's it. Now let us see the next sum. So now we'll study derivatives of inverse function. So few of the standard forms are: first d sine inverse x upon dx is equal to 1 upon under root 1 minus x square, where modulus of x is less than 1. Second, d upon dx cos inverse x is equal to minus 1 upon under root 1 minus x square, where modulus of x is less than 1. Next is d upon dx tan inverse x is equal to 1 upon 1 plus x square, where x is element of real number. Fourth, d upon dx of cot inverse x is equal to minus 1 upon 1 plus x square, where x is the element of real number. Fifth, d upon dx sec inverse x is equal to 1 upon modulus of x under root x square minus 1, where modulus of x is greater than 1. Sixth, d upon dx cosec inverse x is equal to 1 upon modulus of x under root x square minus 1, where modulus of x is greater than 1. Next, d upon dx e to the power x, which is equal to ex. Next, d upon dx a to the power x is equal to a to the power x log e a. Next one, d upon dx log e base x is equal to 1 by x. Let us see few examples based on this. So, next example is find d by dx tan inverse 3x minus xq upon 1 minus 3x square. So, let x is equal to tan theta, where theta is the element of pi by 2, minus pi by 2 and pi by 2. So we can write modulus of x is less than 1 by root 3, which implies that minus 1 by x is between minus 1 by root 3 and less than minus 1 by root 3. X value is between minus 1 by root 3 and plus 1 by root 3, which implies that 10 minus pi by 6 and theta, here we can write pi by 6. So we can write in this way, which implies that minus pi by 2, here in this equation we have multiplied by 3 to the entire equation. So this is the result. Minus so 3 theta's value lies between minus pi by 2 and pi by 2. So now y is equal to tan inverse 3x minus xq upon 1 minus 3x square. It is given in the question, so you can write as tan inverse 3 tan theta minus tan q theta upon 1 minus 3 tan square theta, which is equal to tan inverse tan 3 theta, which is equal to 3 theta. Putting the value of theta, we get 3 tan inverse x. And now putting the value of tan inverse x, we will get dy by dx as, from the formula, 3 upon 1 plus x square. So this is the simple part. So whenever remember, whenever this kind of question comes, it is better to consider x as a tan theta. So 3x minus 3x cube, check if it falls into the formula. If it falls into the formula, it is better to so it is the formula for a tan 3a or from trigonometry, or tan 3 theta. It is in the form 3x minus x cube upon 1 minus 3x square. So it is in the form as 3 tan theta minus tan q theta upon 1 minus 3 tan square theta. So instead of tan 3 theta, we can write this formula. So if it is in this form, then you have to just consider x is equal to tan theta to solve this problem easily. Okay, let us do the next question. The next question is find d by dx cos inverse 4x cube minus 3x for first x is in between, x value lies in between half and 1, and second x value lies in between 0 and half. So we'll consider here, let theta is equal to cos inverse x. Therefore, we can write x is equal to cos theta for theta's value between 0 and pi. Now, therefore, we can write y is equal to cos inverse 4x cube minus 3x is equal to cos inverse 4x cube 4 cos q theta. Instead of x we put the value of x, that is cos theta. So we'll put the value of x, then we can write cos inverse cos 3 theta. Now we can write y is equal to, now for the first question we'll solve when x value is between half and 1, which implies that cos pi by 3 and cos theta less than cos 0, which implies that 0 theta and pi by 3. Therefore, we can also write 0, 3 theta and pi, multiplying the overall equation by 3. So in this case we can write y is equal to cos inverse, instead of so cos 3 theta, so we can write 3 theta, which is equal to 3 cos inverse x. Let us see the how to solve the next part of the same sum. So here it is given x value lies between 0 and half, which implies that cos pi by 2 and cos theta and cos pi by 3, which implies that pi by 3 theta and pi by 2, which implies that multiplying the whole equation by 3 we get 3 theta, we get 3 pi by 2, which implies that 0, 3 theta minus pi by 2. What we have done, pi by 2. What we have done here, we have subtract minus pi from the whole equation. So pi minus pi is 0, 3 theta minus pi, and 3 theta minus pi, 3 pi by 2 minus pi, which is pi by 2. So in this case we have the value of y cos inverse cos 3 theta is equal to cos inverse minus cos bracket pi minus 3 theta, bracket closed. Upon solving, we get minus pi minus cos inverse cos pi minus 3 theta, which is equal to pi minus cos inverse bracket cos 3 theta minus pi. So we can write pi minus 3 theta minus pi, which is equal to 2 pi minus 3 theta. Now putting the values, we get of theta, we get 2 pi minus 3 cos inverse x. Therefore, dy by dx is equal to, just we put the value, we get 3 upon under root 1 minus x square. And this is the answer. We'll see the next example in the next session. Before we close today's class, we request you to subscribe, like, and share our YouTube channel among your friends and relatives. Please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded by us. Thank you very much for watching our videos and supporting us. Thank you.